Beneath the mirroring, we have subsurface scattering, which we're not going to go much into it, but the idea after beneath the subsurface scattering is that you have materials that, for instance, the most obvious example of it is when you take a look at your hand and turn it over to the light, and you can see an amount of light going through your hand. That means that a ray of light enters your hand, starts bouncing around the surfaces, and eventually comes out, but it's the energy of that light is much less than it is from a light source, and it's much more scattered than it's much more diffused actually. It's scattering around and it's not clear as it should be. The subsurface scattering in Blender calculates this and tries to represent the real life situations. It also has some kind of a presets for like apple, chicken, cream, stuff like that. So using some of them, first it calculates the scattering path, then it gives a result. It's mostly used when you're doing a character and you have some of the areas that are, for instance, your ears that are semi-transparent. It gives some, it has some light going through it, and it's pretty diffuse, so it can give nice results.
When you look in your layers, in your render layers panel, you have, of course, your render layers, you have the scene layers, mask layers, and all that stuff. Then you have some options here. The only option that we have been talking about so far is the sky, which is more or less important when you're doing this alpha over pre-multiply stuff. And below that you have the passes, the render passes. So let's say every property of a material or of an object can have a special render pass. And I will explain these passes later, but the main two passes currently that are enabled are combined and Z. So combined means that all render passes, all properties are rendered in just one single pass. So you have all your color information, ambient occlusion, everything is just included in this one pass for the selected render layer. So it's just, I mean, combined is just this, you know, what you see here, this is the combined output. Okay, then of course you have the alpha value, and if you control shift click on this render layer again, you can cycle through the different outputs. So if you control shift click on that again, you can here see the alpha, that is white where you have objects and black where it's empty. So this is the alpha pass, and then if you click again you have this Z thing, and this is just white. The reason that it's white is, I mean, there's actually something in there, but the Z doesn't use RGB values from 0 to 1 or from 0 to 255. It's using a much greater range to have more information. So just to show you the Z buffer, I want to, and you don't have to follow right now. Where is it? I think it's normalize. So if you, there's a special node called normalize, and that converts the values that are from, let's say, I don't know, these great range, high dynamic range things, and will normalize it between 0 and 1, so we can actually see that. So what you see here is the Z buffer for the background layer. And now to make things easier so that we can see the whole scene, I want to create a new render layer that has all objects inside. So I just quickly create a render layer that says all. It has all layers active. render that, and then I can show you the output of the Z buffer that includes all objects of the scene. So I put the Z into the normalize node, and here you can see the output of the Z buffer. So you see this is this black and white image that tells Blender the depth of the scene. So with these black and white values we know that some things are more closer to the camera and other things are far away. Now to use this defocus node, we can use this Z buffer, and I will do that. No, I first show you and then I repeat. So for the defocus node, you can go Shift A and then filter, and then you have this defocus node. And we can then feed the image, the output of the render layer into this image, and then the Z buffer into the Z input here. So you have two inputs, one is image and the second one is Z. So we can use that and then blur the image according to the Z value.
So just a quick explanation of this pre-multiply business. So when you have an image that has an alpha channel, it has transparency, right? So you have some RGB channels that has the image in it, and you have an alpha channel which is a grayscale mask that's telling you where it's transparent and where it's not transparent, or it's just an extra channel. So when you're using the alpha channel for transparency, the parts in the alpha channel that are black are masked out. The part of the alpha channel that are white are included 100%. What happens in between is a little bit dependent on what type of image you have. So in the case of where you're using the alpha channel in like the key mode, if the alpha channel is 50%, for instance, and you have a white pixel, that white pixel will show up as 50% less opaque based on the alpha. But there's a certain way of doing alpha that's kind of faster, and it's to take the RGB in the actual image and pre-multiply it by the alpha value. That means in the image that you have in that case, that white pixel is no longer white, it's 50% gray. And then when you use this in, say, an alpha over or a mix node, it has to do less math to do the alphaing. It's faster because the pre-multiplication is kind of baked into the image. It's happened ahead of time. So what that means is, if you get an alpha that's not pre-multiplied and pass it into one of these nodes that's assuming that the alpha is already pre-multiplied, it's not doing this multiplication step at all, and so your white pixel kind of stays white. It doesn't become kind of gray, you know, and you get this really bright line where the alpha is falling off. So in order to get back your proper behavior, you need to like tell the compositor that it has to convert this to a pre-multiplied alpha type. And that's available in, either you can do it in each alpha over node, in which case if you have a whole bunch of them, it's converting time after time again, or you can add a converter and you can add an alpha convert in your node, so then when you pass it out, it's actually been pre-multiplied. And or, to make life more confusing, you can actually do it ahead of time in the renderer. So somewhere in here,
the alpha, right?
Yeah, is this alpha? And so you can use sky straight alpha or pre-multiplied. So the sky option is kind of funny. It means that the sky color is going to be in the image, So, you know, for instance, if you have a monkey against the sky and you use sky, it's going to actually have the sky color in the RGB channels, even though the sky is at 0 alpha. And that's kind of what people do by default because they want to actually be able to see the sky color. What that means is, though, that the sky is there in the alpha channel, and so you might actually end up seeing it even when you're trying to alpha over something and mask out, and you don't really care what the sky color is. Pre-multiply is going to do a full pre-multiplication of the alpha, so those parts of the image that are alpha 0 are going to be just gone. They'll be disappeared. And the straight alpha is going to render the image without pre-multiplying the alpha and without having the sky color being there. And so if you do a straight alpha render, you'll no longer see this gray sky color anywhere. It'll just be black. And it'll be a straight alpha similar to the sky other than that. So that's kind of the 3 options you have. You can also, in each render layer, exclude the sky from rendering. So for instance, in the monkey render layer, you might not want the sky, and in the boxes you might not want the sky, and you kind of only want it on the background. So you can also like get the sky out of the layers that really need an alpha when you're doing the compositing. So kind of, if you're careful about if you know about this pre-multiplication business and you're careful about excluding the sky from layers where you don't want it to show up, you're kind of more or less pretty sure that you're going to get no little rims of ugliness around the stuff in your alpha overs. If you do get those rims of ugliness, just play around with the options until you find a combination that doesn't. Sometimes you can mentally kind of click something that shouldn't be clicked, and then you have to kind of hunt for it after.